Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is just a quick description of what closures are. So the whole idea of a closure, or at least why it matters, is that basically data in a programming language is scoped, meaning it only exists in certain parts of your language, which is good because you don't want all your data existing all the time. It eats up a lot of memory. So depending on how and where you declare your variables in any programming language, there comes a point where the variable no longer exists, and you can then release it from your memory. So in programming languages like C++, where there isn't, where you kind of have to manage your own memory, you can then go back and clean up that garbage. You have to just go back and delete those variables, make sure they get removed from memory. But as far as global data goes, as far as again stuff that's scoped, it'll automatically remove it, which makes memory management easier. Now JavaScript is a higher level language, so it has what's called garbage cleanup, or I forget what the exact term is. But basically, what happens is that the language itself is monitoring all of its variables for its continued use. So if it sees that this variable is never referred to again in the code, it'll just dispose of it for you. And while that's nice, the cost is that it makes it easier to program something because you don't have to worry about all this memory management stuff. But it also means that you have that constantly going on, which can be a hit to performance when you're doing very large scale, large processes. For web development, probably many situations that won't be an issue. Okay, so basic bottom line, the point is that variables, the existence of data in a programming language can be kind of complicated. But to keep it simple, we're just going to say the data created in a function only exists in that function. So if I were to create a function, so const myfunc equals this, then I were to do const apple equals 5, I have 5 apples, save. If I were to console.log, well, if I were first to invoke the function, so myfunc, and then console.log apple. Okay, save, and then run this code. So let me just clear all that out. Node, well, let me go back to the root. Test node testing.js. It's going to throw me an error. Okay, apple is not defined. But wait a second, didn't you just define apple over here? So why? Well, technically, the minute this apple variable only exists within these curly brackets, so only exists within the context of the function's execution. The minute the function is done executing, okay, this variable gets disposed of. So it no longer exists. This reference apple doesn't no longer exist outside the function. Okay. So what I can do is anything that's inside the function, anything that's inside these curly brackets does have access to apple. So what I could do is I could return a function. I could return a function that returns apple. Okay, that's all it does. So then now what I'll do is I'll say const show apples equals myfunc, and then we'll use show apples instead in the console log. Show apples. Save. And let's run the code. Nope, I don't want to click on that. And see, there we have access to the variable 5. Why? Because even though the function is called outside of the curly brackets, the definition of the function, what the function does, is inside the curly brackets. So in that case, it still has access to the 5. Okay, so I could do all sorts of cool stuff. What if I wanted to make a function that allows you to add 2 apples. Well, let's make this an array. So the first item in the array is the one that shows you apple. The second function is one that just basically adds 1 to apple. Okay, apple plus plus. So here we have an array with 2 functions. One that shows you apple, the other one that adds to apple. Now here's the thing, now when this function runs, this array comes out, so I'm going to destructure that array. So the first function that comes out is the show apples function, so we'll do this. And then the second function is one that adds an apple, so we'll call it grow apples. Okay, now I have those functions going into grow apples and into show apples. Okay, so then what do? I'm going to first do a grow apples. Well, first let's do a show apples. Console.log show apples. And then we will do a grow apples, just so you can see that one gets added. It's all referring to the same variable. Save. Oh, we have an error. Assignment to a constant variable. Oh, because I made this const. So let's make this let, so that way we can change it. Save. And there you go. See, first it's 5. That's when we do the original show apples. Then we do grow apples, which adds 1 to apples. And then we do show apples. So long as these functions are defined from within the function, I can access all the data from the function anywhere. So basically I just return all the functions that allow me to play with all the data inside, and I can do all sorts of cool stuff. And again, every time I run my func, it's creating a new copy of those functions. So it'll create a separate apple. So if I were to do this again, so if const here, let's just copy that part, Control C. Except now it's going to be show apples 2, grow apples 2, because it's the second time we do this. So this will be show apples 2. We'll see that show apples 2 is still going to be 5, because it's no longer referring to the first time we ran the function. When we ran the function again, it created a new execution of the function, which created a new apple and returned a new set of these 2 functions that operate independently. See? So basically, if I would actually show both of them side by side, show apples, and then show apples 2, both in our console log, okay, we'll see that it's 6 and 5. Because again, this one we already added 1 to this one, and this is a separate execution of the myfunc. That's all closures is. The idea is that you can take a function and make it have a life that goes beyond its execution by returning functions that access the data inside the function, and using this, you could actually pretty much mock object-oriented programming in a function, which is the only way you can do it in certain languages, because certain languages just don't have objects. They only literally everything is done in functions, so you have to do this kind of stuff in closures like this. But that's all it is. So all a closure is just taking advantage of the scoping of data inside of a function, and being able to access the data inside the function by using functions that are defined in the function and returning them. So that's all I did. That's it. So it's just playing with scope. That's all it is. So what matters is just, again, where things are defined, what is their scope. If you understand those 2 things really well, it makes it really much easier, much more suave to be able to move data around and do fancy things to create the control over the data that you want. Because see, now you can't directly ever edit Apple. So that's one benefit of this. You can never change Apple. The only way you can change Apple is the way I let you, through the functions that I passed out. So the only thing you can ever do is add 1 to Apple. So apparently you can't eat apples because I didn't make a function where you could subtract an apple. You can just keep growing and collecting apples, and only at 1 at a time. You can't add 5 to apples. You can't divide apples. You can't multiply apples. The only thing you do are the things I gave you the ability to do. Um, again, which is powerful. Okay, it's powerful. Again, the idea of being able to control how how other parts of your code can use your data is pretty nice. So that's that. See you guys later. Have a good one. Ciao.